Our next presenter is Jonathan Rogers, the Chief Executive Officer of Locus Bioenergy Solutions. They were with us at Intercom Dallas in February and shared a great presentation. They're back here at the Oil and Gas Conference to talk about their biosurfactant. And I think they're also going to share with us some of the tax credits that are available in Texas for using this product. It's a great product to enhance your oil recovery out of wells. In addition, it has ESG value for your company. So help me welcome Jonathan Rogers with Locus Bioenergy Solutions. Remember, he's also available for one-on-one meetings today and Tuesday and Thursday. And we also will have a group Q&A with all the Capital Accelerator presenters on Tuesday morning, the 18th, 7 a.m. You'll want to dial in for that. John?
Thank you, and I appreciate the opportunity to talk at Intercom on behalf of Locus Bioenergy. So the first question people probably have is, what is Locus Bioenergy and what do they bring to the market? Well, in a nutshell, what we do is we produce high-potency biosurfactants that previously were only viable for the pharmaceutical delivery of drugs or the high-end cleaning market, personal care market. We're actually bringing them to the oil and gas market to solve some of the oil industry's biggest problems. The attraction of biosurfactants is not only do they outperform traditional chemicals, but you use them at a fraction of the dosage rate. So the overall cost of treatment goes down. And in addition to that, they're 100% sustainable and they're green. And as you'll see through this presentation, what it's all about is extracting more oil from the ground, from the reservoir, because these chemicals can actually loosen and mobilize more of the oil that's present in the reservoir, get that oil out at a lower cost. So we call them award-winning green oil field treatments because last year, 2019, we actually were awarded the Best New Technology of the Year award, both in Appalachia and here in Texas. So we're very proud of those awards. So the first question before we even talk about what are biosurfactants, well, what are surfactants? So surfactants are an essential part of the chemicals that we use in the oil and gas business, and also the chemicals we use every day. Basically, washing up liquid is a surfactant. And what do they do in the oil field? Well, basically, we change the wettability of a reservoir. So we make it, say, preferentially water wet. So the oil that's naturally trapped in that rock actually is mobilized. So we can actually recover the oil. So that's what surfactants do. And why biosurfactants are so interesting for us is if you look at the graph on the left-hand side, a traditional surfactant that we'd use, say, for a frac, you can see here that to get a surface tension reduction, which is one of the things that we look for in evaluating products, to get a surface tension reduction from 70 down below 45, we needed about 1,000 ppm. So that's about a gallon per 1,000 barrels if you're doing a frac treatment. You can see that the product that we offer, the biosurfactant, requires 1/50th of the dosage rate. Now, once these products are actually in the reservoir, what do? Well, on the right-hand side, you can see that if you have an oil-impregnated calcium carbonate reservoir, on the left-hand side, what you're looking at is a bottle which is just the rock itself and the natural water that occurs in the reservoir. And you can see that there's no oil being removed from that oil-impregnated rock. On the right-hand side, what you can see is with the biosurfactant that Locus offers, you can see that you're mobilizing more oil. You can see the close-up there, significant amount of oil released. Now, what I'll show later in this presentation is that translates into our operators recovering 50% more oil from a given well from the addition of this treatment. And the ROI on this is phenomenal. So the ROI, it pays for itself typically within a few months. And we've had sustained production, which again I'll show, which has lasted for 7 months after one single treatment. So biosurfactants, I mentioned before that they'd only really been used in the pharmaceutical and personal care. And the reason for that was nobody could make them at scale. There's been papers such as these talking for the last 20 years about the phenomenal properties that they have. Not only do they use, again, just a fraction of a traditional surfactant, but they also do things that traditional surfactants don't do. They absorb onto rocks and they slowly desorb. And one of the most telling phrases here is that biosurfactants can potentially replace virtually any synthetic surfactant, and not only replace them, but introduce some physical chemical properties that normal surfactants don't have. So that's the whole premise of Locus Bioenergy and our parent company, Locus Fermentation Solutions. We have found a way to make these products at scale. We can make tens of thousands of gallons a month of these extremely high potency, very high quality, very high potency biosurfactants, which now are viable for the oil and gas industry. And this is what's so exciting about it. So for the non-chemist there, what is a biosurfactant versus a traditional surfactant? Well, it's really about what they call active sites. So you can see in the top left-hand corner there that a biosurfactant is a very complex molecule. It's almost like a pharmaceutical complexity. And you can see all of those highlighted elements in there. And each one of these is like an active site, a site where you're going to have some sort of action taking place. Compare that to a traditional surfactant. It's almost like looking at a color picture, a black and white picture. So this is why biosurfactants are so interesting, and they can do more with less, because one molecule of biosurfactant can outperform a molecule of a traditional surfactant. Now, one thing we want to say, we talk about biosurfactants, but there is nothing live. There are no microbes put into any wells. We harvest these products from a fermentation process. It almost looks like a microbrewery. So we remove the biosurfactant. Again, it looks like maple syrup. It's already purified. It has nothing live in it. And we treat it after that just like a traditional synthetic chemical. But it has these phenomenal properties that I mentioned about being able to dislodge oil from reservoirs. So it's been recognized by the Texas Railroad Commission, that basically runs the oil and gas and regulates oil and gas operation in Texas, as what they call a tertiary enhanced oil recovery technology, or EOR technology. And the Texas RRC has been encouraging technologies to come forward, and to do this, they actually implemented a tax break on the so-called severance tax that each operator has to pay on every barrel. So each operator has to pay the state 4.66% of its selling price as what they call a severance tax. Now, to encourage people to increase more oil, produce more oil, they came up with a severance tax credit that basically would cut that severance tax in half to 2.33% if you could put in a technology which would significantly boost the production. So we're proud to say that in May of this year, our technology was approved by the Texas RRC as a tertiary EOR technology. So all of the operators that use this, or will use it from now on, will qualify for a 50% tax break on all the oil they produce on that lease, not just the incremental oil, and they will get it for 10 years. So this is a phenomenal advantage for our technology and for our operators that use it. So basically, to put that in perspective, for a medium to large size producer in Texas, say in the Permian, that's producing 100,000 barrels a day, at today's oil price of $40 a barrel, in tax breaks alone, that's $32 million a year of tax break, which more than pays the treatment itself. And this is the reason that we and our customers are very excited about it. And this is the reason that we're getting a lot of interest in the market and have a lot of field trials scheduled in the next couple of months. One of the reasons the product also works so successfully is what they call the Micelle size. This is basically the smallest aggregate, or the way the molecule aligns itself in water. And why does this matter? Well, for most of the shale wells where the big production push has been over the last few years, these are extremely ultra low porosity reservoirs. And in the press, it's often said that we are only recovering at the moment between 8 and 10% of that oil in place through fracking. And the reason for that is where the oil is trapped in the rock, these pore sizes are so small that a typical surfactant cannot penetrate them to actually liberate the oil. Now, the graph at the bottom shows the pore size distribution for a Wolfcamp shale in the Permian. So the natural cavities, pores in this unfracked rock are between 3 and 18 nanometers. Now, to give you some comparison, the human DNA, the width of a human DNA is 2.5 nanometers. So we really are talking about the ultra low porosity rock. But if you take a typical frac surfactant that we use, this is shown at the top here, it's about 100 nanometers. So obviously there's no way that that typical surfactant can penetrate into these small pores in the rocks and change that interfacial tension and release that oil. Even some of the products that claim to be on the market now, nanoparticles or nanofluids, even they, the smallest of them, are 15 to 20 nanometers. Now, they can only have partial, if any, penetration into these small pores. Now, the great thing about our biosurfactant is the micelle size, or that particle size that's dissolved in the water, is 1.2 nanometers. So we can penetrate and liberate oil from even the smallest pore size in the rock. Now you can see here that on the right-hand side there's a diagram of a frac, and obviously what we're trying to do with fracking is break up that rock and try and liberate more oil. In addition to the large fracs, there's going to be a network of micropores and microfracs, and maybe some of the surfactants can penetrate into those, but again, there's nothing size-wise that can penetrate into these small pore sizes where 92% of the residual oil that we don't recover is kept. So here is some data that shows what we actually did in a conventional series of wells. This is up in Appalachia, and this is a 70 well project. So we've been treating 70 wells in this field for the last 4.5 years. Now, what you're looking at with that graph is the straight line is how these wells were predicted to decline in production over time. And it's a pretty standard technique to do this. You will actually work out based on a certain decline rate as the pressure goes down, how your production will drop off over time. What you can see here is that we started adding our Assure EOR treatments in the middle of 2016. And what you saw straight away is we were changing that decline curve. So we're flattening it out. And over this 45 months that we've been treating these 70 wells, what you can see is the area in green is the extra production that we produced from this field that without our chemical would not have produced. So basically there's a 70% increase in the rate produced from these 70 wells over this time, an extra 58,000 incremental barrels. So very high ROI for our customer. 1.5 to 2 was the ROI on this. So they're delighted with that. And obviously we have then expanded this now to over 300 wells with 20 operators, both in Appalachia and in Permian. And we have tremendous interest in field trials in Q3 and Q4 to expand these treatments. Now we talked about conventional. Well, obviously I mentioned before that the real potential for this chemical is unconventional or shale reservoirs, these ultra low porosity reservoirs, which most of the oil production today, certainly the Permian, comes from. And this is the actual case that we finally got our first Texas RRC tax credit for. And you can see here that we started applying this chemical just over a year ago. And you can see that the line on the left is the decline curve for those 9 well lease. And you can see immediately after we started putting the chemistry in, that area in green, we had a significant increase in production. So we actually changed a 9% decline to a 15% increase in oil. And again, we put it down to this surfactant able to penetrate deep into the reservoir and mobilize more oil. So what does this look like? So the Texas Railroad Commission, what you're looking at on the right is the letter that the oil company in the Wolfcamp Spaybury in Permian received from the Texas RRC, confirming that for them, all production on that lease for the next 10 years will get this 50% severance tax. It's granted again for all the oil produced on the lease, not just that incremental oil. And at $40 a barrel for a big producer, it's worth about $32 million a year. We have an industry experienced team. I'm very pleased to say that we have some of the experts from the chemical business, and these are some of the companies that they've worked for. The technology I'm talking about today is just one of a raft of technologies we're developing. What you can see here is commercialized on the left-hand side. Again, we're selling to 20 operators, over 300 wells in the Permian and the Appalachia region. 2020 is the phase 2. We're developing these biosurfactants now for saltwater disposal. And long-term, we're looking at hydro inhibitors and asphaltite inhibitors, some of the biggest challenges for the oil and gas industry in the business today. This is our go-to-market. We don't want to have a large fleet of trucks. We don't want to have 600 service people. What we do is we stick to what we know well, which is the chemistry, the fermentation, producing the chemistry, and devising the applications for it. So we are partnered with the companies that have the accounts with some of the biggest companies in the industry. And we have a series of wholesale distributor agreements with these big operators. And we're covering over 80% of the US market through these partner companies. We also do have some customers where we're going direct to. This is how we get our case histories. And this is our go-to-market model that we think is set to accelerate in the rest of this year and into 2021. So to summarize, we believe, a absolutely unique IP-awarded technology. It's the only chemistry technology recognized by the Texas Railroad Commission for this 50% tax break. We have scalable, low-cost manufacturing. We've just been awarded ISO 9000, so the product quality is also guaranteed. We have an industry experienced team. We have over 300 case histories of these products. We have an asset-light business model. And what we're seeking now is growth capital to allow us to scale up and meet the demand that we've got in this post-COVID-19, as operators who no longer can drill for oil are looking for these low capex ways to recover more from reservoirs and increase production. What we like to say is that Locus Bioenergy, we're offering improved oil recovery and sustainability as the norm. So in these days of ESG, this doesn't have to be an either-or choice. We can offer increased production plus sustainability. And I'll be very pleased to answer any questions anybody has. Thank you very much.